This is Math 6, Module 6, Lesson 13, describing variability using interquartile range, or the IQR. Now, given a set of data, students will describe how the data might have been collected. Students describe the unit of measurement for observations in a data set, and students should calculate the median of the data and describe the variability in the data by calculating the interquartile range. Now, if you remember in Lesson 12, the median was used to describe a typical value of a data set. We've also used the mean as describing the typical data. But the values in a data set vary around the median. What is a good way to indicate how the data vary when we use a median or an indication of a typical value? Okay, so that's what we're going to be doing with the IQR. We are going to be indicating how the data varies around the median. Just like when we used with the mean, we talked about the MAD. When we use the median, we're going to talk about the IQR. Okay. Now we have restaurant A, B, and C. If you remember from lesson 12, we talked about these with the French fries. Okay, and so this is restaurant A, B, and C's French fries count. Exercise 1 through 4 says, in lesson 12, you thought about the claim made by a chain restaurant that the typical number of French fries in a large bag was 82. Then you looked at data on the number of fries in a bag from 3 of the restaurants. How do you think the data were collected, and what problem might come up in data collection? Okay, so if you're thinking about it, how would that work? Well, or not how would it work, but how did they probably collect this data? Probably went to the restaurant and ordered a bunch of bags of large fries. Sometimes the fries are broken, so they might have to figure out what to do with those and either count them as a whole, discard them, or put them together and make whole fries. So if you got 2 half fries, you got a whole fry then. Now, what scenario would give counts that might be representative of a typical bag? Well, different workers might put different amounts in a bag. So if you bought the bag at lunch, you might have different numbers than if you did in the evening. The restaurants might weigh the bags to see that the fry was constant despite the size of the fry. So you could have the same weight of fries even though you have a different count of them. So if you got a really long one that weighs a lot, or you could have 3 that add up to the same weight. So you got a different count. Now number 2, come over here to number 2, it says the median of the top half of the medians of the bottom half of the research of each of the 3 restaurants are as follows. So the median of the top half of restaurant A is 87.5, and the median for the bottom half, because remember the median is the middle, so we got a top half and a bottom half. So that bottom median would be a 77. For restaurant B, it was 83 and 76, and C was 84 and 78. The difference between the medians of the 2 halves is called the interquartile range. So let's talk about that. We have the difference. Well, what do we talk about in math when we refer to difference? We're talking about subtracting something, right? So it's between the medians of the 2 halves. So we would take this median and subtract this median from it. Same thing here. Take this median and subtract 76 from it. 84 and 78. And that would give you the 3 interquartile ranges. So 10.5, 7, and 6. Because we did exactly what I just said. We would subtract these medians here. Okay. So when you think of interquartile range, you need to think of range as a difference. So we need to subtract. And that goes for any range normally. You're going to look at the highest value, and then you're going to look at the lowest value. Or in this case, we're going to look at the two medians for the interquartile range. But I could have also said, what is the median for range A? I'm sorry, restaurant A. And we would just took the maximum number of fries and the minimum number of fries, and that would have given us an entire range. It would not have given us the interquartile range, but it would have given us the range of fries. So which of the restaurants had the smallest IQR? Well, restaurant C had the smallest IQR. Indicates that the spread around the median number of fries is smaller than the other two. About half the data are within a range of 6 fries. Okay, notice what they said there. About half the data is within the range of 6 fries. So what that's talking about, so for restaurant C, we have the median of, let's see here, the median for restaurant C was probably about 81, or was it 82? I can't remember. I think it's about 81. Okay, but then the upper half here was 84. The lower half median was 78. And what they're saying is, if we take this number, the 78, and this number, the 84, this right here is about 50%. Okay? And the range is only 6. From 84 to 78, it's only 6 fries. So about half of the data, or 50% of the data, is within 6 fries. Okay? So that would mean that the median is a pretty good description of what is typical. The median of the bottom half of the data is called the lower quartile, and we represent that as Q1. Q1, the lower quartile. And the median of the upper is called the Q3. So that is the Q3. We got Q1 and Q3. About what fraction of the data would be between the lower and the upper quartiles? Well, we should have about 50%. Okay. Because if we go from, where's these? If this is 50% between 78 and 84, then below it here in this area would be about 25%. And above this area would be about 25%. So about a quarter above and a quarter below. Okay. Now it says mark the quartiles for each restaurant on the graph. Okay. So here's the graph of each. So this would be the median of Q1. Okay, and this would be the median of Q3. Okay. Now, it says, does the IQR help you decide which of the 3 restaurants seems most likely to have 82 fries in a typical large bag? Well, 82 would be about right here. Okay, let's call this 82. Now, which one of these do you think would probably have 82? Now, notice that this is restaurant C, B, and A. They kind of go in opposite order there. Probably not going to be B, right? There's too many on the, it's too close to one edge. C, it might be right here. That's close, but this right here is almost dead center. So let's see what they said. The IQR does help decide which restaurant is most likely to have 82 French fries. A typical large bag of a typical, in a typical large bag, because the IQR explains the variability of the data. Because restaurant C has the smallest IQR, the middle half of the counts of number of fries in a bag is really close to the median. In addition, restaurant C has the smallest range. Okay, so this is almost dead center, and it also has the smallest range. I'm sorry, that's not it. Restaurant C here, it is close to the middle of the range, but it also has the smallest range. Okay, this is more varied here for restaurant A, so that's the reason why they marked it out, because there's such a big variance there. We've got to remember, whenever we have a smaller, less variability, we're going to have more accurate answers. Okay. Now it says, example 1, finding the IQR. Read through the following steps. If something does not make sense to you, make a note and raise it during class discussion. Consider the data. There it is. Creating an IQR. We're going to put the data, first of all, in order from smallest to largest. Now, it looks like it is already in smallest to largest here. So we don't have to worry about that. Now, find the minimum and the maximum. Well, here's the minimum, and here's the maximum. 1 in 17, right? Now, that would be the range of this data. 17 minus 1 is 16. So we'd have a range, but we're not talking about range, we're talking about the IQRs. So let's find the median now. Let's go with, how many numbers are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 17 numbers, okay? Which means I can have 8 below it and 8 above it. So that means I would divide by 2, and that gives me 8.5. So I would go up to 9. So the 9th term is my median. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 10th, or the 9th number is 10. So that will be our median. There it is. Now it wants us to find the lower quartile. So what is the lower quartile? Remember, it would be the median of the lower quartile, or the lower range. So since there's 8 on this far end, we have to take the 2 middle numbers, right? Well, if we take 4 and 6, 4 plus 6 is equal to 10. Sorry, getting ahead of myself here. It's equal to 10. If we divide that by 2, we get 5. So that is our Q1. Now, if we look over here, the 2 numbers just happen to be 15. So if we add those together and divide by 2, of course, we get 15 again as the upper. That is the median. 5 is the median of the lower quartile, or Q1, and 15 is the median of Q3. So you find the median, and then you break it into two, and then you find the other two medians. Okay. Now calculate the IQR. Since we have the two medians, we can say 15 minus 5 there, and we get 10. That is the interquartile range. It is the range between the two medians of the Q1 and the Q3. Page 5. When should you use IQR? Now this is important to remember. The data for the 2012 salaries for the Lakers basketball team are given in the two plots below. Okay. Now, this one is in reference to the mean, and this one is in reference to the median. Remember, I told you in the very beginning, when we have median, we're going to use MAD to talk about the variability. When we have the median, we're going to talk about the IQRs. Okay? So it says the data are given in hundreds of thousands of dollars. What would a salary of $400,000? What would a salary of $400,000 be? Okay. Well, the salary would be 40, and then we have 100,000. So that's 40 100,000. So we would just multiply those. Okay. And all we have to do is say 4 times 1, that's 4, and just add all the zeros. There's 1, 2, 3, 4, 5, 6. I put too many. There should only be. Oh yeah, no, it didn't. 6 zeros. So that would be $4 million. 100,000 there. Now, it says the vertical lines on the top plot show the mean and the means plus and minus the MAD. The bottom plot shows the median and the IQR. Which interval is a better picture of the typical salaries? Which one is the typical salaries? Well, the median and the IQR seem to represent the typical salaries better than the mean plus or minus the MAD. The mean salary is above all but 5 of the salaries. Both the mean and the MAD are affected by the 3 unusual large salaries in the data set. Okay. So these 3 right here has stretched the mean this way a little bit. Okay. And it doesn't show to be quite accurate. So the median would be the best. Now, to find the IQR, you order the data. These are your steps. First, order the data. Second, find the median of the data. Then third, you're going to find the median of the bottom half, or Q1, and the top half, that's Q3, or the upper quartile. The IQR is that difference. So to find the remember, we're finding IQR. So the fourth thing you're going to do is subtract the Q3 and the Q1. And that's going to give you the length of the intervals that include the middle 50%. The median and the two quartiles divide the data into 4 sections. What about with about a quarter of the data in each section? 2 of the sections are between quartiles, so that the interval between the quartiles would contain about 50%. So I'm going to show you what we're going to do here. We're going to start having some dot plots here. Okay, we got some type of values down here. Doesn't matter. But you're going to start drawing what's called a box and whisker plot. Okay, and you're going to start by drawing let's call it a median down here. This is the median. Then you're going to find the Q1. Let's call this median. This is Q1. And let's say down here is Q3. This is the median of Q3. Okay. So that means that down here is 25%. In between here is 50%. And above it is 25%. Okay. But just know, you got to know that in between Q1 and Q3, there should be 50%. Okay. And if you'll think about it in terms of the MAD, we have here, we've got a MAD. Let's say the mean is here, right here. And we said the MAD is equal to 3. And let's say here is 3, and here is 3 to the left. Distance to the left and distance to the right. Well, right here would be about 50% of this data. No matter if down here there's some values, there should be about 50% in between the two ends of your MAD. Okay, so it kind of relates back to the IQR as well.